Okay, so we're going to be solving exponential and logarithmic functions today. So really putting everything about exponential functions, logarithmic functions all together. We've already talked about this before, so if I have b raised to the x power equals b to the y power, your bases are the same, so you can drop the bases and set your exponents equal to each other. So here I have 3 to the x plus 2 power equals 3 to the 3x minus 16 power. So I can drop my bases since they're both 3. So I get x plus 2 equals 3x minus 16. I'm going to solve for x, so I'll subtract x, add 16. So I get 18 equals 2x, divide by 2, so I get that x equals 9. Now, if I don't have the same bases, then I'm going to try to get the same bases, which we've done before as well. So 8 to the x power equals 2 to the x plus 3. I can rewrite 8 to be 2 cubed, and that's to the x power equals 2 to the x plus 3. So this is 2 to the 3x equals 2 to the x plus 3. My bases are both 2 now, so I can drop them and say that 3x equals x plus 3. Let's subtract x. I get 2x equals 3 and divide by 2. So I get that x equals 3 halves. Next example, I have 3 raised to the x power equals 27 raised to the 3x minus 16. So they don't have the same base, but I can get them to be the same. So 27 is the same thing as 3 cubed. So this is 3 to the x equals 3 cubed to the 3x minus 16 power. So 3 to the x power equals 3 to the, when I raise power to another power, multiply, so I'll distribute. So to the 9x minus 48 power. Now that my bases are the same, I can drop them. So x equals 9x minus 48. So subtract 9x. So negative 8x equals negative 48. Divide by negative 8. So I get that x equals 6. Now, when we can't get the same base, what we do is we take the log of each side. So here, I have 2.4 raised to the 3x plus 1 power equals 9. So 2.4 and 9, there's nothing I can do to rewrite them as the same base. So what I'm going to have to do here is I'm going to take the log of each side, and I'm actually going to have to use a calculator for this now. So when I do this, I'm going to take log of 2.4 raised to 3x plus 1 power equals the log of 9. So I'm using a common logarithm. I'm using a base 10. I'm going to use the power property now. So I have an exponent in my logarithm, which means I can take that exponent and pull it out to the front. So 3x plus 1 times the log of 2.4 equals the log of 9. And I'm going to work to get x alone. So my first step is I'm going to divide both sides by the log of 2.4. So when I do it to the left side, I'm just getting rid of it completely. So in the calculator now, and I'm using a TI-84 calculator, I'm going to put in log 9, and I'm going to close the parenthesis, divided by log 2.4, and hit enter. So on my left side, I have 3x plus 1 equals, it's 2.5097, and it goes on for a long time. But I'm not going to round yet. I'm going to round at the very, very end. So my next step to get x alone is I'm going to subtract 1. So I get 3x equals, and in the calculator, I'm just going to hit minus 1. And it's 1.5097 and all that other junk. And my last step to get x alone is I'm going to divide by 3. And in the calculator, I'll hit divide by 3. And I get 0.503256. It goes on and on and on. We are going to round 3 decimal places. So we're going to round to the thousandths. Okay, so our answer is 0.503. So we rounded at the very end. So when you can't get the same base, you're going to take the log of each side. And then you wait to round till the very, very end. Next up, I have log base 3 of x minus 5 equals 2. So the x minus 5 is in parentheses, so that has to stay together. I only have one logarithm written, so there's not a whole lot to do right now other than put it straight into exponential form. So my base is 3. I'm raising it to the second power, and that equals x minus 5. 3 squared is 9, and that equals x minus 5. And now we're just going to add 5 to each side, and I get that x equals 14. And always double check that your solution does not, when you plug it in, you're not ending up taking the log of a negative number. So when I plug in 14 right there, 14 minus 5 is 9, and I can take the log of a positive 9, so that's fine. So 14 is my solution. I've got log base 8 of x plus 3 equals log base 8 of 3x minus 9. In this problem, I have 2 logarithms, and they're set equal to each other, and the bases are the same. So when that happens, I can drop the log in the bases and just say that x plus 3 equals 3x minus 9. And I'm just going to solve for x. So subtract x, add 9, so I get 12 equals 2x. Divide by 2, so I get that x equals 6. And always double check. If I plug in 6 here, 6 plus 3 is 9. I can take the log of 9. And then plugging in 6 here, 3 times 6 is 18, minus 9 is 9. And I can take the log of positive 9 as well. So x equals 6 is my solution. I've got log of 45x minus log of 3 equals 1. I've got 2 logarithms, but they're not set equal to each other. They're being subtracted. And we've talked about the properties of logs before. So when you subtract 2 logs, you can make it 1 by division. So I can write this as log of 45x over 3 equals 1. And now there isn't really anything to do except for put this in exponential form. So my base is 10. It's raised to the first power. And that equals 45x over 3. So I get 10 equals 45x over 3. So now to solve for x, I'm going to multiply both sides by 3. So I get 30 equals 45x. I'm going to divide both sides by 45. So I get that x equals, both can reduce by 15. So this is x equals 2/3. And when I plug in 2/3 right here, 45 times 2/3 is going to be a positive number. It's going to be positive 30. So that works out just fine. And last example, log base 5 of 11 equals x. So I only have one logarithm. I don't have anything to do here other than put this in exponential form. So my base is 5. I'm raising it to the x power, and that equals 11. Now, I have a base of 5 and a base of 11. I can't get those to be the same base. So what I'm going to do here is I'm going to take the log of each side. Now, the reason why I couldn't put my original equation in the calculator is because the calculator only computes a base of 10. And this one has a base of 5. So I couldn't just jump straight into putting it in the calculator. So I'm going to take the log of each side. So log of 5 to the x power equals the log of 11. I'm going to use the power property, so I'm going to take the exponent and I'm going to pull it out to the front. So x times the log of 5 equals the log of 11. And I need to get the x alone, so all I'm going to do here is I'm going to divide both sides by log of 5. So x equals log 11 divided by log 5, and that's what I'm going to put in the calculator. So in my calculator, I'm going to put in log 11 and close the parenthesis after the 11 and divide it by the log of 5, close parenthesis, and I get that x equals, we're going 3 decimal places, so it equals 1.4, it's 898, so it's really 490. So x equals 1.490. And that is it for solving exponential and logarithmic functions.